Good morning, everyone. My name is Gabriel Silva-Atencio, and it is truly an immense privilege to present my work here at the very first International Conference on Leadership in AI, which is a crucial and highly anticipated part of the ICONS series. This conference is not just any event in the field of AI. It's a landmark gathering that brings together the brightest minds and top experts from all corners of the world. It serves as a dynamic platform where we can engage in in-depth sharing and lively discussions about the latest, most cutting-edge ideas and research. When we think about the importance of this conference, it's like a global melting pot of AI knowledge. Here, researchers from different continents with different cultural backgrounds and research focuses come together. For example, we might have a scientist from Asia who has been working on AI in healthcare, and a researcher from Europe who specializes in AI for environmental monitoring. Their interactions here can lead to new perspectives and innovative solutions. Today, I will be delving into a topic that is at the very core of modern digital transformation. The title of my presentation is A Unified Model for ITIL and DevOps, Achieving Velocity Without Sacrificing Operational Resilience. This topic isn't just some abstract theoretical concept. It has far-reaching real-world implications for how we manage our IT services on a daily basis. In the current era of computational science and engineering for society, the way we manage our IT services is like the very foundation of a skyscraper. It's not just a minor factor. It directly and significantly impacts our ability to innovate and effectively support community needs. For instance, let's take a closer look at a large-scale e-commerce platform. Picture a bustling online marketplace with thousands of products and millions of customers. Efficient IT service management is like the well-oiled machinery behind the scenes. It can ensure seamless transactions, which in turn play a vital role in supporting the economic activities of the community. Think about all the small businesses that rely on these e-commerce platforms to sell their products. Without proper IT service management, these transactions could be disrupted, affecting not only the businesses but also the consumers. This research of mine proposes a systematic framework. This framework is like a meticulously well-designed map that can guide us through the complex landscape of bridging the gap between traditional service management and modern agile delivery. Traditional service management has its own well-established set of rules and processes. These rules have been developed over years and are focused on maintaining order and control. On the other hand, modern agile delivery is all about speed and flexibility. It allows organizations to quickly adapt to changing market conditions. Our framework aims to combine the best of both worlds, taking the stability and structure from traditional service management and the speed and adaptability from modern agile delivery. Let's explore this in more detail. Traditional service management is like a well-organized army. It has strict hierarchies, detailed procedures, and a focus on long-term stability. For example, in a large enterprise, the IT service management team might follow a set of standard operating procedures for every task, from software installation to network maintenance. This ensures that everything runs smoothly and predictably. However, in a rapidly changing market, this can sometimes be too slow. Modern agile delivery, on the other hand, is like a group of guerrilla fighters. They are fast, flexible, and can quickly adapt to new situations. In a startup, for example, the development team might use agile methodologies to quickly develop and launch new features. But this flexibility can sometimes lead to a lack of stability. Our framework is like a bridge that connects these two different approaches. It takes the best parts of both and creates a new way of managing IT services. We will explore how we can move past the old, long-standing debates. For a very long time, there have been heated discussions in the IT community about whether to focus on speed or stability. But we firmly believe that there is a way to find a generative synthesis. This synthesis is like a powerful, all-in-one tool that empowers organizations to be both fast and stable. It's not an either situation. We can have the best of both. Let me give you a little more background on why this research is so important. In the digital age, the competition is cutthroat. Organizations are constantly under pressure to be able to respond quickly to market changes. At the same time, they simply cannot afford to have system failures. For instance, take a financial institution. It needs to process transactions rapidly, whether it's a simple online payment or a large-scale investment transfer. But it also has to ensure the security and stability of its systems. A single system failure could lead to significant financial losses and damage to its reputation. Let's look at a real-life example. A well-known bank once faced a system outage during a peak trading day. The outage lasted for several hours, and it caused panic among its customers. Many customers lost money, and the bank's reputation took a huge hit. This incident shows how important it is for financial institutions to have a reliable IT system. Our proposed framework is not just a theoretical concept floating in the air. It has been painstakingly developed based on real-world data and rich experiences. We have conducted in-depth studies of various organizations, ranging from small local businesses to large multinational corporations, and their IT management practices. Through this extensive research, we have identified the key factors that can help in achieving the delicate balance between speed and stability. These factors are like the building blocks of our framework. As we move forward in this presentation, we will look at the different components of our framework in great detail. We'll start by examining the core principles that underpin the framework. Then we'll move on to the practical steps for implementation. We will also discuss how it can be implemented in different types of organizations. Whether it's a small startup with limited resources or a large multinational corporation with complex structures, our framework has the potential to bring about positive, transformative changes. Let's first talk about the core principles. These principles are the foundation of our framework. They are like the roots of a tree, providing stability and support. One of the core principles is the integration of processes. We believe that by integrating the processes of traditional service management and modern agile delivery, we can create a more efficient and effective IT service management system. Another core principle is the use of data. In today's digital age, data is king. By collecting and analyzing data, we can make more informed decisions and improve the performance of our IT systems. After understanding the core principles, we will move on to the practical steps for implementation. These steps are like the steps on a staircase, leading us towards the goal of achieving a unified model for ITIL and DevOps. Finally, we will discuss how our framework can be implemented in different types of organizations. For a small startup, the implementation might be more focused on simplicity and flexibility. For a large multinational corporation, the implementation might require more complex planning and coordination. Thank you so much for joining me for this session. I'm really looking forward to sharing more in-depth insights with you in the following parts of the presentation. Let us begin by defining the problem. For years, there has been a perceived conflict between speed and stability in IT. In our modern digital economy, the demands are non-negotiable. We must provide rapid service delivery while maintaining absolute system stability. However, DevOps and ITIL are often seen as opposing forces. DevOps is frequently characterized by its focus on speed, agility, and continuous delivery, moving fast and occasionally breaking things. Conversely, ITIL is traditionally seen as focusing on resilience, control, and standardized, sometimes rigid processes. This has led to a zero-sum game mindset where organizations feel they must choose between being fast and flexible or being secure and formal. Furthermore, existing integration models often fail us. They are either purely descriptive lists of problems or overly simplistic tool integrations that lack a comprehensive architectural blueprint. This gap in the literature and practice is what my research aims to fill. To understand where we are going, we must look at where we have been. Early studies, such as those by McLean and Tida, emphasized ITIL's role in aligning IT with business objectives through formal control. Meanwhile, DevOps emerged as a necessary movement to break down silos, as noted by Rahim and Osalaja. A significant turning point occurred in 2019 with the release of ITIL-4, which explicitly incorporated Agile, Lean, and DevOps concepts into its service value system. Since then, we have seen emerging solutions like site reliability engineering, which makes resilience measurable through SLOs and error budgets, and DevSecOps, which shifts security and compliance to the left. We also see policy as code as a method for automating governance. Despite these advancements, a remaining gap exists. There is still no comprehensive, prescriptive meta-model that synthesizes these diverse elements into a single, unified design theory. We have the pieces of the puzzle, but not the full picture. This brings us to our primary research question. How can a unified architectural model be designed to systematically integrate ITIL-4 and DevOps, enabling both high velocity and operational resilience? To answer this, I propose the UIDM-VR, or the Unified ITIL DevOps Model for Velocity and Resilience. This is a mid-range design theory that does not just add DevOps tools to an ITIL process, but rather synthesizes ITIL-4's service value chain with the DevOps continuous delivery cycle. It represents a move beyond additive integration toward what I call generative synthesis, where the whole is greater than the sum of its parts. It is important to note that at this stage, the model is positioned as a conceptual blueprint. While it is built on rigorous logic and expert feedback, it serves as a foundation for future empirical validation in diverse organizational settings. The methodology employed for this study is Design Science Research, or DSR. Following the framework established by Aparicio and colleagues, DSR is ideal for creating and evaluating innovative IT artifacts designed to solve complex organizational problems. My research was conducted in 3 distinct phases. First, a systematic literature review was performed to identify the fundamental meta-requirement for the model. Second, in the artifact design phase, I derived specific design principles from these requirements and engaged in iterative prototyping based on expert feedback. Finally, the evaluation phase was robust. It included a Delphi-based review with a panel of 6 academics and 8 practitioners to ensure theoretical and practical relevance. I also utilized an illustrative case study involving a hypothetical bank transitioning to microservices, conducted technical action research with partner organizations, and performed a formal theory evaluation to assess the model's completeness and clarity. The first key innovation of this model is the dual-loop value stream engine. This represents the core architecture of UDM-VR. Imagine a 3-dimensional structure where 2 cycles intersect. On the horizontal axis, we have the ITIL service value chain, encompassing the stages of plan, improve, engage, design and transition, obtain and build, and finally deliver and support. On the vertical axis, we have the DevOps continuous delivery spiral, moving through code, build, test, release, deploy, operate, and monitor. The innovation here lies in the resilience feedback loops. Operational data does not just stay in a log file. It flows directly from the monitoring stages back into the planning and improvement activities of the I-chain. This enables continuous learning and a dynamic balance of control. By aligning strategy on the horizontal axis with execution on the vertical axis, we ensure that every technical release is synchronized with the broader business objectives and service standards. Our second innovation addresses one of the most significant bottlenecks in IT governance. Traditionally, change advisory boards, or CABs, create sequential delays and compliance bottlenecks because they rely on manual, human-led reviews. The UIDVR proposes CAB as code. In this model, the role of the CAB evolves from reviewing individual changes to defining policy standards in machine-readable code. These coded policies are then integrated into the CI/CD pipeline, which automatically checks every change against the requirements. This results in zero sequential waiting. Compliance becomes a continuous part of the delivery process rather than an external hurdle. The impact is profound. Governance shifts from being a human-performed barrier that stops work to becoming an automated, enabling screen that ensures safety at the speed of code. This allows developers to move fast while the organization maintains the rigorous oversight required for modern enterprise operations. The third innovation is SLO-driven improvement. In this model, service-level objectives and error budgets are not just operational metrics. They are treated as first-class artifacts during the initial service design phase. They are continuously monitored during live operations, but the real power comes from the dynamic feedback loop. When an error budget is consumed beyond a certain threshold, it is not just an alert for the operations team. Instead, it becomes a primary input into the planning activities of the development team, triggering an automatic reprioritization of work. If a service is unstable, the model dictates that the next sprint must focus on resilience over new features. This formalizes SRE principles within the broader service management framework. By making resilience metrics actionable development inputs, we ensure that operational health is never sacrificed for the sake of feature velocity. Fourthly, we address the socio-technical alignment. Technology alone cannot solve the conflict. We must align our teams and metrics. The UIDM-VR advocates for stream-aligned teams that have end-to-end ownership of a service from its initial conception to its daily operation. To support this, teams are evaluated using a balanced scorecard that includes both velocity and resilience metrics, for example, measuring deployment frequency alongside the change failure rate. This eliminates the conflicting incentives that often exist when development is rewarded for speed and operations is rewarded for stability. When everyone is responsible for the full lifecycle, resilience becomes a shared, measurable goal. This approach is based on configurational studies that link these integrated practices to enterprise-level outcomes, ensuring that the organizational structure supports the technical goals of the unified model. The evaluation results confirm the model's potential. The expert panel showed high agreement that the UIDM-VR addresses critical industry pain points, recognizing it as a significant step beyond existing integration approaches. Practitioners specifically found the model clear and applicable for designing target operating models. In our illustrative case study of a financial institution, we tested two scenarios. In scenario 1, a security policy breach was detected by the automated pipeline, causing a build failure and providing instant feedback to the developer. In scenario 2, an SLO breach triggered an automatic improvement ticket that was prioritized without requiring manual management intervention. These scenarios demonstrate how the theory functions in practice. Ultimately, the UIDM-VR qualifies as a design in action theory because it provides clear, prescriptive guidance through its constructs, models, and methods for real-world implementation. In discussion, the main contribution of UIDM-VR is that it challenges the zero-sum mindset. It proves that velocity and resilience can be mutually reinforcing through careful architectural design. By introducing a control system that adapts based on real-time feedback, like error budgets and policy violations, we create a dynamic balance that static models cannot achieve. Furthermore, by automating compliance through CAB as code, governance actually becomes an accelerator for speed rather than a bottleneck. However, we must acknowledge the limitations. This model assumes a modern cloud-native architecture with high levels of automation. It requires mature data collection and integration capabilities to function effectively. As it stands, this is a rigorous design theory, but it is not yet a fully empirically validated solution. It is now ready for the next stage of longitudinal testing in live environments. To conclude, the UIDM-VR provides the first comprehensive prescriptive design theory that systematically integrates ITIL and DevOps. We have summarized our key innovations: the dual-loop value stream engine, governance as code, SLO-driven improvement, and socio-technical alignment. We predict that these will lead to measurable KPI improvements, such as reduced change lead times, lower MTTR, and increase deployment frequency. Looking forward, our future work will focus on longitudinal empirical validation through in-depth case studies and the development of maturity models specifically for highly regulated industries. We also plan to explore the integration of AI ops for predictive resilience, moving from reactive to proactive service management. Thank you for your time today, and I look forward to your questions regarding this blueprint for high-speed, resilient service management.